Good morning, CP Pre-Calc. What we are doing today is we're moving on from our trig identities. So we just completed our trig identity quiz yesterday. And what we're moving on is to solving trig equations. And we're going to start with day one of solving trig equations. Now, the thing about our trig equations is that our trig equations tend to have infinite number of solutions. And the reason they have infinite number of solutions is if we go back to our unit circle. If I go back to my unit circle, I can have infinite many solutions. Because if I look at this, for example, if I said, when is cosine negative 1? I'm aware that cosine is negative 1 at pi, or also 180. But that's if I travel from 0 to pi. That angle measurement is pi radians. However, if I do another entire revolution from that value of pi, I'm going to be traveling 3 pi from my initial point. And at 3 pi, my cosine value is also negative 1. If I travel another revolution, which would be another 2 pi, travel another revolution, I would be at 5 pi, and that cosine value would also be negative 1. So we're going to have infinite many angles that can have the same value. So we can have infinite many solutions. However, today, for our initial day of solving trig equations, we're just going to work on the interval between 0 and 2 pi, where 0 is inclusive and 2 pi is not inclusive. And we'll go over that. Now, we are going to need our unit circle. So either take your unit circle out from home or pull it up on your computer, because you will be utilizing the unit circle while we solve trig equations. In addition, we are going to work with radians. So that's the unit we should be working with in this section. So let's take a look at my first problem. Now, in my first problem, we're going to write this. Problem number 1. It's going to be cosine theta equals 1/2. Okay. And what I want to emphasize here is we said that we're going to solve for an exact value. That means we're not using decimals. We're going to find the exact value on our unit circle. And we're going to find the solutions on the interval between 0 and 2 pi. Now, what I mean by inclusive is, see, 0 has the bracket. That means 0 is included within my interval. 2 pi is not included within the interval. Okay, so remember, this is similar to me writing 0 is less than or equal to theta, which is less than 2 pi. And I'm using theta because that's the angle measurement I'm trying to find here. So I want to find what the value is between 0 and 2 pi, where 0 is inclusive and 2 pi is not inclusive. Now, this is kind of simple here, guys, in an example that I just gave you. If I wanted to find, in this case, cosine theta equals 1/2 on this interval, what I would do is I would be going to my unit circle. And we're going to be utilizing this a lot. And I want to know cosine. When is cosine equivalent to 1/2? Well, I'm going to go to when the x value is equivalent to 1/2. And if I look at my unit circle and I ask myself, when is my x value equivalent to 1/2? It's equivalent to 1/2 at pi over 3 and at 5 pi over 3. So that means that would be the two answers on my interval between 0 and 2 pi. Because I'm going to travel one revolution around. And I want to see when that x value, and I'm saying x because remember cosine is equivalent to x, I want to look at when my x value of my coordinate points is equivalent to 1/2. So in this case it's at pi over 3, and down here it's at 5 pi over 3. So I will have two solutions for theta. So here I'm going to say theta is equivalent to pi over 3 and let me write that a little neater. Pi over 3 and 5 pi over 3. Those would be my two solutions for when cosine is equivalent to 1/2 on the interval between 0 and 2 pi, 0 being inclusive. Okay, that same concept. We're just doing these basic problems right now. So let's take a look at this one. If I gave you sine of theta is equivalent to 0. Now remember, we just said we knew cosine theta would be x. Sine theta, we have to remember, our sine theta is equivalent to y. So again, we're going to our unit circle and we're going to say to ourselves, if cosine is y, when is my y value equivalent to 0? All right, guys, so when is that y value equivalent to 0? And if I want to look here, my y value is equivalent to 0 right here at 0. And if I go all the way around the circle, when does my y value, is it equivalent to 0 again? Well, it's equivalent to 0 here at pi. If I go around, I got a -1 for my y, and that's it. I'm done. I don't have to write 2 pi because 2 pi is not inclusive within my interval. So my two radian measures that have a sine value of 0, because my y value is 0, would be 0 and pi. So I'm going to go back over here, and I'm going to say, when is it going to be equivalent to 0? Well, theta would be 0 and pi. Those would be my two solutions. So now, guys, remember, you don't have to now remember the unit circle because we are home or remote learning. Your unit circle could be in front of you every single time you solve these problems, when you're taking a quiz or assessment on these problems. So there's no memorization involved. Right now, it's just being able to have your unit circle and apply it when we're solving our problems. All right, so let's do another one. Now let's take a look at this one. All right, guys, how does this slightly differ? Now, what if I said tangent of theta equals the square root of 3? Now, this was easy. Cosine was x. Easy to find when I looked at my unit circle. Sine is y. That was easy to find. I looked at the y values. Tangent is different. Tangent would be y over x. And we want to look for a combination on our unit circle that would simplify to root 3. So a combination of y over x that would simplify to root 3. Now, guys, obviously, it's going to be one of the problems that has a root 3 on top. Now, the other thing I want us to remember is, in this case, they're telling me tangent is positive. We should all know when tangent is positive. If we think of our quadrants, and we think of our x and y quadrants, we went over. When do we know our sine, cosine, tangent are positive? We know all students take calc. That means tangent would be positive in quadrant 1 and in quadrant 3. So I need to look for a value that will reduce to root 3 that's in quadrant 1 and quadrant 3. So remember, it's going counterclockwise. 1, 2, 3, 4. So let's take a look here. Let's think about this. When can I reduce to a root 3? So if I'm saying when can I reduce to a root 3, I'm looking and I see, again, tangent is y, so that means I would want my y value to have the radical 3. If I look here, that has an x value at radical 3. That means it would be in the denominator. In this case, that's not going to help me. But if I look at this value here, I have a y value of root 3 over 2 and an x value of 1/2. Let's take a look at that. And that's, again, at pi over 3. So it's a y value. We have a y value of, we have y over x. It would be root 3 over 2 over 1/2. Now, guys, let's think about this. This is a improper fraction. How do we simplify it? You guys, you keep the numerator, change the multiplication, division to multiplication, and multiply by the reciprocal. So we flip our denominator. When we do this, what happens, guys? What happens? You are easily able to see that our 2's cancel out. That simplifies to root 3 over 1, which is root 3. That is what I wanted my tangent value to be. That checks. So therefore, I want x to be 1/2 and y to be root 3 over 2. So what value in quadrant 1 was that at? We look at it back here again. In quadrant 1, that was at pi over 3. Therefore, when I look, my first answer would be pi over 3. Now, in quadrant 3, tangent is also positive, but it's going to be slightly different. I want my x to be a 1/2 and my y to be a root 3 over 2. However, x and y are both negative in quadrant 3, but that is okay because a negative over a negative would simplify to a positive. So we're going to look when we have a negative 1/2 for our x and a negative root 3 over 2 for our y. And if I come over here and I take a look at that, let's take a look. If I take a look, I just want to make sure that we're zooming in on that properly. If I take a look at that, I'm saying I want a negative 1/2, we want a negative 1/2 as the x. So here's our negative 1/2 at the x and a negative root 3 over 2 as our y. So right over here, 4 pi over 3. If I simplified that, that would also be root 3. And if you want me to show you, because that's 4 pi over 3, you would just say, if this was a negative and that was a negative, I put a negative root 3 over 2 over negative 1/2, they would cancel both to be a positive. So I would get the same answer when I simplified to be root 3. So in this case, the two answers on that interval from between 0 and 2 pi would be pi over 3 and 4 pi over 3. All right? Now, is it going to get a little harder? Today, a little, but not much. What if I gave you an example like this? Just slightly harder, but not much. If I gave you 2 sine theta minus 1 equals 0.